Yeah, hello, this is Benjamin.
Hi, Benjamin.
Hey, Benjamin.
Hey,
Yeah.
morning.
Good morning, good evening.
We'll just wait for a few more people. Give them time to join. Just wait a minute or two.
Sure.
Okay, I think it's 2 minutes past the hour. Xing, do you want to make intros and intro Benjamin?
Oh, yeah, sure. Hey, thanks, Benjamin, for doing this presentation. Benjamin is a maintainer of etcd. So he's going to give an overview of etcd today. So Benjamin, do you have slides you want to share?
Yeah, I have slides. Yeah, can I share my screen and get started?
Yes, please.
Absolutely.
Yeah, sure. Let me share my screen firstly. Can you see my screen?
We can do.
Yeah, okay. Let me get started. Okay. Oh, sorry, just 1 second. Okay. Okay, my name is Benjamin Wang. I'm a senior software engineer at VMware. So I'm also one of the etcd maintainers. My GitHub account is AHRTR. So it's the acronym of ad hoc real-time reporting. It's one of the projects I did many years ago. Okay, today's topic is overview on etcd. Actually, it's also a deep dive. So I will speak a little fast. I will try to get it finished in 30 minutes. Yeah, the agenda contains 2 parts. The first part is etcd architecture and its components. In the beginning is the high-level introduction to etcd. Next is the architecture, followed by the storage. etcd includes 3 kinds of storage, which are WAR file, snapshot, and BoldDB. Then is the replication. I will introduce how the leader replicated data to the followers using RAF. Afterwards is the etcd server. etcd server is the core of etcd. Of course, is the most important part of etcd. etcd also has a client package, is a Golang client SDK used by application to communicate with the etcd server. At the end of the first part, I will talk about the end-to-end workflow, how etcd process a pull request. The second part is the current priorities of the etcd community. Okay, last is the question and answer session. Okay,
That's
the introduction.
Brilliant.
Sorry, go ahead.
No, I was just going to say that's brilliant. Thank you. Looking forward to this.
Okay, sure. Okay. The etcd is the distributed key value data store. So there are two key points. The first key point is a key value database. It means it isn't a relational database. Instead, it's a kind of no-circle database. This is the first key point. The second key point is strong consistency. Based on the CAP theory, no any system can achieve all of the three goals, nor can etcd. So etcd is actually a CP system, which means it sacrifices availability at the interest of consistency. It can't serve write request if the core isn't satisfied. Core means majority. For example, for a 3-member cluster, the core is 2. For 5 members, the core is 3, etc. etcd can solve linearizable read request by default if the core isn't satisfied. But etcd can solve serializable read request even when the core isn't satisfied. Yeah, the following are two examples how the client issues serializable request. For the first example is the etcd counter. User can set the consistency equal to S, which means serializable read request. The second example is set the serializable parameter to true for the head endpoint. Yeah.
Just a quick question there. What's the difference between linearizable and serializable read requests?
Yeah, it's a good question. In serializable is a concept in the database. Database have some isolation level. For example, repeatable reads and serializable, right? Serializable means, for example, if multiple clients send a request to the server at the same time concurrently, and the server can guarantee all the requests can be processed one by one. In the client perspective, which means all the requests will be processed one by one, but the order isn't guaranteed. For example, there are 3 requests 1, 2, 3, probably 1, 2, 3, or 2, 1, 3, or 3, 1, 2. The order isn't guaranteed, but the server can guarantee the request will be processed one by one. This serializable means. Linearizable is strong serializable. It's even strong. From the etcd perspective, linearizable means if the core isn't satisfied, then the server cannot serve the request. Linearizable means the server will handle all the requests order one by one, and the order is guaranteed. Is one specific order. This is the linearizable means. Is that clear?
Gotcha. Makes sense.
Okay, got it. Okay. Version the latest 3 versions are 3.6.0, Alpha 0, and 3.5.4 and 3.4.18. 3.4 and 3.5 are stable release, and for 3.6 we haven't cut the branch yet, so the main branch is still for the 3.6. Yeah, if you are interested in the new feature in 3.6, please take a look at this link. Yeah, this is a simple summary on the new feature in 3.6. Yeah, this diagram describes the high-level architecture of etcd. etcd server is the most important component. It gets all other components connected. The client side can be command line tool, etcd counter, or client application, depending on the etcd client Go SDK. In this diagram, it used the etcd counter as the example. The client sent a request to the gRPC server, and the gRPC server dedicated all requests to the etcd server. Yeah. The request may be read or write request. For write request, it needs to get consensus from majority. So the etcd server just get the request wrapped in a proposal and deliver the proposal to RAF. And the RAF will take care of the log replication. Once the log has already been received by majority of the members, then the RAF mark the log as committed and notify the etcd server the log is ready for apply. The commit, apply are a concept in etcd. There are 2 different phases of workflow. Afterwards, etcd server perform the apply workflow. it saves the key value data to the watchable store. The watchable store supports MVCC. It means multi-version concurrent control, which means it keeps all the history of each key. The key value store eventually processes the data into the backend database. For the read request, it also needs to make sure the current member has already applied all the committed log. Simply put, it means it needs to make sure the current member has the latest data as the leader. Once is confirmed, it reads data from the log store and responds to the client. Otherwise, it needs to wait until the log data catch up to the latest commit at the leader. Of course, the client can issue a serializable request. Then at the server, just no need to wait at all. It just reads data from the log store and responds to the client directly. Yeah, this is a high-level architecture. Any question before I move on? Okay, no question. Let's move on. Okay. RCD has three kinds of storage files, which are WAR file, snapshot, and BuildDB. On the right side is the layout under the date RCD data directory. The snapshot file are actually V2 snapshot, the V2 snapshot. The V3 snapshot is only used for data replication. Leader needs to replicate the log to the followers. If a follower lag far behind, then the leader may replicate the whole DB file to the followers. It will generate a V3 snapshot in this case, and send the snapshot to the follower. Yeah, this is the only use case for the V3 snapshot. So I will talk about each storage file later. Okay, this is okay. Let's look at the WAR file firstly. Yeah, WAR file means read or head log. Read or head log file. Each WAR file is about 64 megabytes, and only the recent 5 WAR files are preserved is configurable. The leader replicate the log to the followers using rough. Once each member receives the log, the first thing is to persist them to the WAR file and append only. When an RCD member restart for any reason, the log in the local WAR file, starting from the latest snapshot, are replayed. So which means once the data are saved in WAR file, they will not be lost. Yeah, it's just similar to the redo log in MySQL database. Okay. Yeah, this diagram is the detailed format of the WAR file. Each WAR file consists of a series of records, or serial record. The first 8 bytes each record is the length of the record. It's encoded in the lead engine, and the record size is actually stored in the lower 56 bits. In order to make sure each record is always 8-byte elements, there may be some paired bytes. If the most significant bit is 1, then the lower 3 bits in the most significant byte is the paired size. Yeah, it's little detailed information. The record data can be decoded into a structure. The first field is the record type. You can see there are 5 types. The second field is the CLC checksum. The last field is the real data bytes. The data can be further decoded based on the type. For example, if it's the entry type, it can be decoded in its structure. It contains term, index, type, and data. Again, the data can be further decoded based on its type. Yeah, in general, the entry has 2 categories, which are normal entries and config change. Yeah, this is the detailed format of the WAR file. Yeah, there is a tool, rcd-dump-logs in RCD projects. It can be used to analyze the WAR file. The below screenshot is an example. The format of the data, term, index, type data match the format in previous slides. So I'm not going to go to each field one by one. It's a lot of details. We can you can take a look offline.
And just a quick question there. So the write ahead logs only grow to 64 meg, and is that sort of a hard limit per file?
Yeah, it's hard limit. And yeah, 65 is a hard limit, but maybe the WAV file may be a little bigger than the 64 megabyte. Yeah, it may be a little bigger. It's okay. You know,
Gotcha.
because each WAV file may be, you know, if the left side is, if the WAV file is less than 64 megabyte, if the last WAV entry is bigger, maybe beyond the 64 megabyte, a little bit.
Yeah, that makes sense, especially with the padding for the recorder.
Yeah. Okay.
So Benjamin, sorry, one question. So does the WAL file actually include the data being written, or it's just a reference or pointer to it? So when you say like 65 megabyte limit for a WAL file, does it include the actual data being written, or it doesn't?
Yeah, it includes the real data. You see the example, K1, V1 is the real data.
Sure. So then, if you're writing large data, then you're pretty much exhausting your quota of 5 WAL files, right?
Yeah, it's good. Yeah, it's good question. Actually, there are a couple issues in the community. We are trying to figure out how to define the max wall rank entry and max request size. We need to get this sorted out in the near future. Yeah,
so
I will talk
what's the
about
largest amount of data you recommend, or HCD community recommends as far as data?
Yeah, it's a good question. Yeah, you know, HCD is designed to serve small metadata, so big metadata is not recommended. This is first recommendation. The second recommendation, HCD support transaction. Each transaction can have multiple requests. So by default, the max request in a transaction is 128. If I remember correctly, 128 requests in a transaction. But somehow some users maybe have thousands of requests in one transaction. So yeah, we save our issue from our contributor. So we need to figure out how to limit the max request in one transaction. This is also a to-do list in my to-do list.
I see. So even for a single transaction, like what's considered too large? How many megabytes for a request?
Yeah, the max request size is configurable. The user can change the max by default is 1.5 megabytes is by default, but user can change it.
Right, but given that these WAL files are limited to 65 meg, it seems you can't go beyond 65 meg, or if you have a few tens of megabytes, you're exhausting that quota pretty fast, right?
Yeah, exactly. Yeah.
But Ardalan, you can have multiple write ahead logs.
Yeah, 5 only.
Yeah, the recent 5 will be reserved, but it's also configurable. The user can reserve more files.
I see. Okay. Thank you.
Yeah, sure. Okay, let's move on. Yeah, the V2 snapshot. The V2 snapshot is suffixed with the .snap. Its recent snapshot file are preserved by default. It's also configurable. Yeah, it only contains the term index and membership information, which means it doesn't contain any key value data because V2 store data had already been deprecated in 3.4 and is already decommissioned in 3.6. But the data is still maintained for 3.5 rollback. Eventually, they will be gone in future release. A new snapshot file is automatically generated on every 100,000 applied log. If the user kick off the cluster downgrades, a new snapshot file will also be generated immediately. Once a snapshot file is generated, then all the WAL logs other than the snapshot index are compact. So anyway, the summary, the V2 snapshot only contains term index and membership information. There's no real data in this file. Yeah, this is the key point. Okay, storage about to be. BoldDB is a project under the LCD organization. It's forked from BoldDB dashboard. It's an embedded key-value database, which means it runs as a library in other applications, such as LCD. Yeah, it's the most important storage for LCD. All of the key-value data is stored in the BoldDB. Key-value data is saved in buckets. Bucket is similar to table in relational database. It's just a logical concept. But in physics, the BoldDB uses the p-plot tree to manage all the key-value records. All the data are saved page by page in a disk file. Usually the page size is 4 kilobytes. There are 4 kinds of page. The branch page and the leaf page are equivalent to the internal node and the leaf node in a b-plot tree. The first 2 pages in a file are reserved for the metadata. The meta page. There may be some free pages in the file, and the IDs of all the free pages are saved in the free page, free list page. Yeah, this is the simple introduction for the BoldDB. Okay. Yeah, there are a lot of details about the BoldDB, but I want to highlight the most important one. This is the most important feature I think the BoldDB has. The most important feature is it never modify data in place. Let's work with an example for this in this diagram. This diagram is coming from my WeChat channel. The original file is missing, so I just create a snapshot of the picture from my WeChat channel. Yeah, let's work with an example. For example, if an application updates some data in the leaf page 8, then BoldDB loads the leaf page and its parents all the way to the root into memory. And then BoldDB updated data in memory. When the client application commits the transaction, BoldDB allocates new pages in disk file. And save the updated data into the new page in disk. Of course, BoldDB will try to get the free page in the first step from the free page list, if any. Obviously, the old page keep unchanged during the transaction. Such design has 2 benefits. The first benefit is the write transaction doesn't affect any other read transaction. The read transaction can always read the same data during the read transaction, so it guarantees the repeatable read. The second benefit is it guarantees the atomicity. If the read transaction failed for whatever reason, it doesn't corrupt any existing data. The only side effect is the DB file may be enlarged after the transaction, but it shouldn't be a problem, because the new allocated page can be reused later, and the user can also manually reclaim the unused page. Yeah, any question on this diagram?
So that, I assume, implies that there is some sort of garbage collection or cleanup that happens during a compaction or defrag. Will you cover those steps as well?
Oh yeah, it's a good question. This is different from the compact and defragmentation in LCD. Compact and defragmentation is concept in LCD. This is a concept in the BoldDB. They are different level. Yeah. Okay. Yeah, we are talking about the BoldDB uses the b-plot tree to manage the data disk file, page by page. All the data saved page by page, but some page may be free, not used at all. So the user can write the file into a new file. So all the free page will be compact. This is similar to the defragmentation and LCD, but it's different.
Okay, understood. Yep, that makes sense.
Okay. Yeah, there are also two tools which can be used to analyze the BoldDB file. The first one is the LCD-dump-db. Yeah, is included in the LCD project. The second one is the command line tool provided by the bold file itself. There are two examples. Actually, they are doing similar things. They are reading data from a bucket. For example, in this first example, the DB, this is the file name. The method is the bucket name. It reads all the key value from this bucket. For example, term, consistent index, and conf states. In the second example, it just, the key is command is sub command, and the DB is the file name. Method is the bucket name. It just lists all the keys in the first step. And in the second command, it just read this is the method is the bucket name. Consistent index is the key. It reads the value for the key. It do the similar thing. The format is, the current body doesn't supported format option is in my dev branch. Yeah, so far.
Yep.
Yeah. Okay. Yeah, I wrote a series article in my WeChat channel about 2 years ago, but obviously it's in Chinese. I maybe provide some summary in English in the future. Yeah. Anyway, if you are Chinese, feel free to take a look in this link. Okay. Okay. RAF is the key package to achieve consensus between members. LCD depends on RAF to maintain a replicated state machine. If you want to have a deeper understanding, I recommend you to read the introduction on the package and read the original paper. Use the two links. The RAF follows a minimalistic design philosophy. It only implements the core RAF algorithm. The storage and the network transport are handled by the etcd server. The two main functions provided by the RAF are leader election and log replication. The member which gets the majority vote is elected as the leader. Only the leader replicated log to the followers. LCD server and RAF talk to each other via channels. From the RAF perspective, they are input channel and output channel. But RAF encapsulates the input channel and exposes the node interface. So LCD server talk to the RAF via the node interface, while the RAF talk to the LCD via the output channel. Yeah. Yeah, actually, the RAF is a standalone package. You can also develop your own application based on the RAF. Yeah.
Is that Raft package used independently by any other projects that you're aware of?
Lots of, many.
Okay.
Not only LCD. Yeah. Yeah. If you open this link, you can see a lot of the introduction on this package. The first link. Okay. Let me go to the next one. Yeah. Yeah, this diagram is the high-level workflow of the RAF. Now, firstly, the client sends a request to the LCD server. Then LCD server gets the request wrapped in a proposal and deliver the proposal to RAF. If the current RAF node is the leader node, it replicates the log to the followers. Once majority receive the log, the leader mark the log as committed. And then notify the LCD server the logs are ready for apply. At last, the LCD server persists the log and send a response to the client. Yeah, this is a high-level workflow. Okay.
So effective. So,
go ahead.
I was just going to say, so effectively, the number of followers adds to the latency to the client request, right? Because they all have to be replicated synchronously.
Yeah, exactly. Yeah.
Yeah, one question I have is, obviously all the writes have to go to the leader for log propagation through Raft. But what about the reads? Like, do reads involve the leader, or each etcd server can serve the reads independently?
Joe, can you say that again? Sorry.
So obviously all the writes involve the leader, because
Yeah.
the leader has to propagate the log to other etcd server nodes, right? What about the reads? Does the reads involve, do the reads involve the leader, or can they be served
Got it.
independently by, yeah.
Yeah, got it. Yeah, actually, the reads can have two types. For the Raspberry read request, then you need to get the communicate with the leader. Make sure the current member has the latest data as the leader. For the serializable read request, you just read the local data returned to the client, which means the serializable read request, the client maybe get the old data.
Stale read, yeah.
Does that answer your question?
Yes, thank you.
Yeah, sure. Okay, this is the RCD server. RCD server is the most important component, and you get all other components connected. It exposes a gRPC API to receive client requests. It also has a RAF loop to communicate with the RAF. So the request may be coming from the gRPC API or RAF. Yeah, this is the most important for the RCD server. If you understand this, you understand RCD server. Okay, RCD server also starts some jobs, such as the job periodically purge WAR file or snapshot file and monitor the file description, something like that. The RCD server also has a key value store, which supports multi-version concurrent control. It processes the data to the backend DB. Yeah, this is the high-level construction of the RCD server.
So just a quick question, just to confirm I'm understanding this. So are the write-ahead logs the transaction logs from Raft?
Yeah, exactly.
Right,
Yeah.
and then they get checkpointed into the BoltDB backend.
Yeah, it's, just mentioned the RCD server has three kinds of storage file: the WAR file, V2 snapshot, and the BoltDB. Yeah, WAR file and the BoltDB are two different storage. They are different. WAR file contain all the history, but the BoltDB, BoltDB for the key value data, it also contains the history. But for the non-key value data, for example, the list or the metadata, it doesn't contain the history. Is that clear?
I see. So does BoltDB get updated when the snapshot happens?
No, the BoltDB is updated each time when the RAF notified at the server some logs are ready for apply. The
Right.
BoltDB is updated in each apply workflow.
Okay. Yeah.
Okay. The RCD server has a client package. The client v3 is the official RCD client Go SDK. The following is a simple example how to use the client v3 package. First, just import the client v3 package. Secondly, just create a client instance using the construction function new. The application needs to pass a config to the constructor. Afterwards, application can call whatever method they want. In this example, it just call the put to put a key value pair to the RCD server. Yeah, this simple example. Yeah, please note the client v2 is already decommissioned, so please do not use it. Yeah, this diagram is very important. Yeah, this is a detailed end-to-end workflow, how RCD process a put request. Firstly, the client sends a put request to the RCD server. The RCD server then proposes the request to RAF. Then the RAF append the log to its log RAF log, and then responds to the RCD server. But the workflow isn't finished yet, so the RCD server cannot respond to the client at the moment. It just watch a channel to wait for the workflow to finish. The leader RAF saved the log into the WAR file in the first step. Just mentioned previously, the RAF follows a minimalistic design philosophy. The storage are handled by the RCD server, so the RAF just notify the etcd server to save the log into the WAR file via the read channel. In the meanwhile, the RAF leader also replicated the log to other followers. Once the leader received the confirmation from majority, including it itself, then it marks the log as committed. Afterwards, the leader, the RAF node notified the etcd server. The logs are ready for apply. Yeah. So when the etcd server finished the apply workflow, it wakes up the waiting coroutine blocked at the step 5. So eventually the etcd server sends response to the client. So this is the end-to-end workflow. Yeah, any question?
Right. So, and again, just a clarifying question here. So effectively, we go to Raft first, and then the etcd server waits for Raft to confirm, and it will save entries to the local write-ahead log. And then when it's gotten confirmation from all of the peers, it stores it in its local database as well.
Exactly. Yeah. Yeah, one more comment, one more comment I didn't mention just now. The leader RAF also needed to broadcast the commit ID to the followers. So in the follower side, they also, in the follower side, the RAF also needs to notify its etcd server to apply the log. Just a similar workflow as the leader. Okay.
So I got one question. So once, I guess it's step 11, where you actually transfer the content from the wall logs into BoltDB, right? Do we purge those operations or that state that was reflected into BoltDB from wall logs, or wall logs remain, they keep the history of all operations since the beginning of time, the same way BoltDB does? Basically, what's missing for me is that given that BoltDB and the wall log and snapshot implementation in etcd are completely decoupled, how do these layers reconcile? How do we purge wall logs? How do we know, for example, how much of the wall state got reflected into the BoltDB database?
Yeah,
because
it's a good question. Yeah,
ahead.
The etcd server had some jobs. One of the job is the periodically purge the wall file, and one job is for the purge the v2 snapshot. Yeah, there's the jobs to purge the file. Another, for the wall file and the BoltDB, they have different package. We have a dedicated wall package to handle the wall file persistence. We have dedicated package for the backend to process the data to the BoltDB. So I'm not sure I answered the question.
Okay, so let me ask the question. So basically, in very few words, is wall log a record of all the work that hasn't been committed to BoltDB, or is it actually a record of all the operations done so far?
Yeah, it's a good question. Each data must be saved in a WAR file in the first step. So which means if the entry is if the key value data is in the WAR file, doesn't mean it's in the BoltDB.
Right.
Yeah, this is first key point, because
once it's in the BoltDB, do we purge that operation from wall file, or the wall file keeps growing?
No, doesn't. The only reason to purge the WAR file is the snapshot. When the etcd server create a snapshot, it will purge all the WAR entry other than the snapshot index. Does that make sense?
Yes.
Sure.
So you do that so that you do not have to have like duplicate data, so that you have it either in the snapshot or in the WAR file. So this way, when you do, let's say if you need to do restore,
exactly.
you can just use either one of those.
Oh, no. no, when the LC server gets start up in the beginning, it will load the snapshot, load the latest snapshot, and replay all the word entry after the snapshot index.
Okay.
Let me see if I can summarize this. So we write to the WAL file first. When we get the confirmation from the peers, we commit it to BoltzDB. Periodically, based on the tuning, the snapshot kicks in. And when we take a snapshot, all the data in the WAL files is compacted into the snapshot. And then the WAL files are truncated. And then we can, and then we can continue to create new WAL files, right?
Yeah, basically correct. Just one minor comment. Yeah, what the overview, I agree with you, but there's one minor comment. When V2 snapshot is generated, it doesn't purge or delete any entry on the disk. It just purge the word entry older than snapshot in memory in the RAW state machine. Is that clear?
Okay, so okay, so the WAL files are not truncated, but they effectively rotate based on how many WAL files you choose to keep.
You got it, yeah.
Right, okay. All right.
Okay.
I didn't quite understand that concept before. This is really useful. Thank you.
Yeah. Okay, let's move on. This is the priority. Okay, the second part, there are some item in the community is working on right now. The item marked with the asterisk are the priorities. The first one is to unify the test framework. LCD has an integration test and end-to-end test. Previously, they have separate test framework, but actually most of the integration test and end-to-end test case have the same or similar logic. So we are working to unify the testing framework. The second one is for the V3 3.5 data inconsistent postmortem. The first link is the postmortem of the issue. If you want to have a quick understanding of the issue, I recommend you to take a look at the second link. Yeah, the second link provides a simple summary on the issue. There are some action items in the postmortem, such as the enhance the data corruption detection code and refactor the LCD server to make the apply code easy to understand and easy to validate. The third item is the for lease. Some requests do not go through RAF. The reason is, the RAF is based on a global logic clock, but the lease depends on the word time. So there's a gap between them. So the item is still in progress of investigation, is in my to-do list. Yeah, it's a priority in my list. The fourth one is
and what's the advantage of moving of doing that refactor?
Oh, sorry, can you say that again?
What would the advantage be of the leases not going through Raft?
Yeah, it's a good question. Just mentioned the leave is based on the word time. For example, when the clients create a lease, the client usually set a time to leave. For example, for 100 seconds. This depends on the word time. But the RAF is a global logic clock. They're different. So there's a gap. Yeah. Sure, there are a lot of detail to clarify, and I use my to-do list. There's a big PR in progress review right now.
And would this mean that would this change mean that leases would have a lesser impact on the etcd server in terms of performance?
Yeah, it's a good point. Yeah, the performance is one consideration. I will think about it. I will try to make sure there's no any impact on the performance. Yeah, it's a good point.
Cool.
Okay.
Sorry, like, are you saying that because leases are not subject to RAF today, that means if etcd servers go down, we may lose some lease data, or we may have some inconsistency? Is that what you're saying?
No. The leaf. I'm not saying all the requests do not go to RAF. Just some of the requests do not go to RAF. For example, the list. For example, if the client application wants to list all the lists, they doesn't go to RAF, just read the local data, which means the client maybe get all the data.
Sale.
This is
Yeah.
one issue. Yeah, another renew is really complicated. So the current implementation is too complicated. So I have bigger PR to reflect the renew. Yeah,
I see.
yeah,
Thank you.
I've sent the link offline later. Yeah. Yeah, and then the next one is for the revision in the response header. Just mentioned previously, etcd server supported multi-version concurrent control for the key value store. So it means the revision only makes sense for the key value data. But currently, etcd server auto return the revision in the response header for other requests, for example, the list. Yeah. The next one is sort out all the min max threshold just now. For example, the user can specify the max request size, but in the meanwhile, we hard code the max word entry limitation at 10 megabytes. So etcd may run into a situation when it successfully processes a request larger than 10 megabytes, but fail to be decoded by the word package. Yeah, we received a real issue from the customer, in the community. There are some other examples as well. So anyway, we need to get all these thresholds sorted out. So it's also in my to-do list. Yeah, I will send out. I will create an issue to summarize this and ask for opinion from other maintainers and from the contributors in the community. The next, okay.
Is there any work being done either in the community or in the etcd project around operators for etcd to deploy in Kubernetes?
Yeah, it's a good question. Yeah, it's not a priority. It's just not a priority in the community right now. I believe there are some third-party projects working on that, and there are also etcd admin to do that. But I don't think etcd admin is pretty simple. I don't think it's a powerful operator right now.
Agreed. Okay.
Yeah.
So if we do that, Alex, you do need to have a Kubernetes first to deploy your operator, right? So I was like, seems to be a chicken and egg issue.
Well, there are other applications other than Kubernetes that use etcd. So for example, like our storage product uses etcd, and I'm aware of a number of other storage systems that use etcd as a key value store. So it's about how do you deploy etcd within Kubernetes.
Okay, makes sense now.
Yeah. Actually, about last year, I was trying to deliver a Helm chart to deploy etcd, so the user can easily deploy etcd in Kubernetes cluster. Yeah, but eventually, I think this is a little difficult. It's a little complicated. It's not that easy. Especially, especially when the etcd server crash or restart, or with scale down or scale in or scale out. It's a little complicated. It's not as simple. Okay. The next one is a new feature. Memory aware server-side throttle is developed by our contributor. Sometimes etcd server may crash due to auto memory. So this feature is to protect etcd from running into this situation. So I did not get time to have deeper review on this PR yet. It's of course in my to-do list. The last one is the namespace quota feature. It's also developed by our contributor. is designed to resolve the multi-tenant use case. Its high-level idea is to isolate the storage for each user and apply different quota on different user. I did not get time to have a closer look at this feature so far, but my immediate feeling is that the best way to resolve multi-tenant use case could be just start a dedicated etcd cluster for each user, or let the client application instead of the etcd to handle the multi-tenant use case. So anyway, I don't think this item is a priority for now. We may revisit it in the future.
So this namespace is not necessarily the same as the Kubernetes namespace, right?
Yeah, it's different. Yeah, it's different,
Okay.
the concept. It's just designed for to resolve the multi-tenant use case for each user to create a different namespace for each user.
Okay.
Yeah, there are some other items, but we did not get time to take a close look at yet. Yeah, that's all for today's presentation. Yeah, thank you for your time. Feel free to let me know if you have any questions.
Thank you so much, Benjamin. And I think, at least for my part, I was asking questions along the way, so that was useful. Is there any questions or comments from the rest of the call?
Benjamin, can you share this slide?
Sure, no problem.
Fantastic.
Yeah, this is really helpful.
Yeah.
Thank you so much.
One question for you, Ben. We're actually looking into upgrading to etcd 3.5, and there are a lot of data loss issues, data corruption issues. You mentioned one of them yourself. Look, has anything significantly changed with 3.5 where these issues are manifesting? Or look, I mean, if you look at the GitHub issue today, you see like a lot of new issues in the last few days regarding data corruption, loss of data. Look, has anything significantly changed since 3.5 or 3.4? Like, what's the cause for these issues?
Yeah, it's a good question. Yeah, I resolved this issue. In 3.5.3. Actually, in the 3.5.4 is also a minor fix. So anyway, the 3.5.4 fixed this issue. You know, 3.4 doesn't have this issue. This is a regression introduced in the 3.5.0.
Okay.
Yeah, there's there are 4 solutions in my. I proposed 4 solutions in total, but eventually I choose a compromised solution because we need to backport the fix to 3.5. 3.5 is a stable release. It cannot accept a huge refactoring of the repo. So the PR is just about, I remember correctly, it's just 300 or 400 lines code change. Yeah, it's not that big change.
Okay.
So just to confirm, in your opinion, 3.5.4 addresses all of the known issues, all of the known inconsistency issues that were found at 3.5.0.
Yes.
Okay. That is
Yeah.
useful to know.
Yeah, if you look at the GitHub issues of the last week, you'll see many data corruption. I understand these have to be triaged and understood, but it seems the frequency of these type of problems have gone up recently. And because of that, we're somewhat apprehensive about to upgrade to the latest version of etcd.
Yeah.
Thank you. Very informative.
So the previous stable version would be 3.4.18, therefore.
Yeah, that just was the previous stable release is 3.4.9, I believe 3.4.9.
Oh, okay.
Yeah, 3.4.9. Oh, yeah.
Thank you. Is there any other questions from the group? No, it sounds we've taken all the questions. Thank you so much, Ben, and thank you, Yijing, for reaching out to Ben. This was a really informative session for me and for the rest of the team. We'll once you share the deck, we'll share it on the mailing list as well. Thank you so much again, everyone.
Thank
And
you, Ben.
have a good rest of your day.
Yeah.
Thank you, Ben.
Thanks.
Bye.
Bye.
Thanks.
Bye.
Bye.
Bye.